In a potential turning point for science and humanity's quest to answer the age-old question, are we alone? The James Webb Space Telescope has delivered its most compelling evidence yet of possible life beyond Earth. The breakthrough comes from an exoplanet named K2-18b, orbiting a red dwarf star 124 light-years away in the constellation Leo. Using Webb's powerful instruments, astronomers have detected molecular fingerprints in its atmosphere. Molecules that, on Earth, are produced solely by living organisms. The key suspect, a so-called Hycean world, a planet covered in deep oceans, wrapped in a hydrogen-rich atmosphere, and possibly teeming with microbial life.
We have found evidence for possible biological activity on an exoplanet. We have found signs of biosignature molecules, either DMS or DMDS or both of which are produced uniquely by life here on Earth.
The gases dimethyl sulfide DMS and dimethyl disulfide DMDS were detected in K2-18b's atmosphere at concentrations thousands of times greater than on Earth. Too abundant, scientists say, to be explained without biological processes. What makes this moment historic isn't just the discovery itself, but how it was made. Webb's ability to isolate light filtering through alien atmospheres marks a paradigm shift in the search for life.
Is that we are demonstrating that it is possible to detect biosignatures around in atmospheres of such planets around nearby stars with existing facilities, and that's a big breakthrough.
K2-18b is part of a class of sub-Neptune planets, larger than Earth but smaller than Neptune. It resides in its star's habitable zone where liquid water might exist. Earlier Webb data found carbon-based molecules like methane and CO2. Now the presence of DMS and DMDs adds a tantalizing biological clue.
The scenario that explains all of this is one where it's a Hycean world that is teeming with life.
But scientists stress caution. The signal has a 99.7% confidence level. Robust but not yet definitive. More observations are needed to rule out all other explanations.
So we want to observe more to get it to a 5 sigma level, less than a chance in a million, a part in a million of a fluke. But we also want to do more theoretical and observational studies to make sure that there is absolutely no other way we can make this molecule without life.
Still, the implications are staggering. For the first time, we may have the tools to detect life on planets orbiting distant stars. This could be the beginning of a new chapter in cosmic discovery.
This is a monumental discovery. It is very important, but we also have to be extremely cautious. The reason is that this is one of the biggest questions we have asked as a species in all of science, and we have to deal with it very carefully in that we want to be really, really robust in establishing whether this is actually life that we are seeing. We want two things. We want more observations to confirm that this signal is robust. We are seeing it at a 3 sigma level. We still have 3 in 1,000 chance of it being a fluke. So we want to observe more to get it to a 5 sigma level, less than a chance in a million, a part in a million of a fluke. But we also want to do more theoretical and observational studies to make sure that there is absolutely no other way we can make this molecule without life. I think it is our responsibility as scientists and as part of a society that we want to answer this very deep question in a very careful and robust manner. But the excitement is still there nevertheless, that we've got the capability to do it now.
In the dark vastness of the universe, one planet may be whispering back.